Section 10.4 Systems of Nonlinear Equations, Part 1. To solve nonlinear systems of equations, our best methods for solving is substitution or elimination, and then in these cases we also might graph. If we can look at graphing, then we can check our answers off of the graph. Okay, so here's an example where we used substitution as a way to solve the nonlinear system. A linear system has an xy power of 1. We don't have that xy power of 1. X squared, y squared is what's making it not linear, a nonlinear system of equations. Okay, so as we looked at before, substitution, we want to pick a variable that's easiest to solve for. In this case, negative y is going to be easier to solve for. So we're going to add over the y, we're going to subtract over the 10, and we get y equals 3x minus 10. Now that's going to get substituted into the remaining equation. If I substitute that into the remaining equation, I've used the substitution method. Okay, so we have x squared plus y squared, but instead of y, we substituted in 3x minus 10 equaling 0. And so notice that top equation, we just plugged in y is 3x minus 10. Squaring, FOIL, multiplies that out properly. We're going to collect like terms. We're going to get one side to be 0. We're going to factor out a greatest common factor. If I set 10x equal to 0, x is 0. If I take x minus 6, set it to 0, we get x equals 6. And now we need to find y. What did we know about y? We knew y was 3x minus 10. If I plugged in 0 for x, then what we're going to end up with is y equals negative 10. And so I have one of the solutions. When x is 0, y is equal to negative 10. Okay, so we're going to do the same thing here. We found out that x is equal to 6. So instead of x, we'll plug in a 6 minus 10. 18 minus 10, we're going to get y is equal to 8. So when x is equal to 6, y is equal to 8. And those are the two solutions to my nonlinear system. Now, if we were to graph, we should recognize this as the graph of the circle from when we learned how to graph circles. This is the graph of the circle centered at 0, 0, radius 10. So that's what we see here. This is just the graph of a line. 3 is our slope, intercept negative 10. And what we should notice is our solutions, like we learned in the graphing method, are where these two intersect. Okay, so substitution. We substituted, we solved for y, substituted in the remaining equation. Once I have a solution, I can check that solution with the graph. Okay, in this next example, we are looking at elimination. Let's see if we could eliminate x squared. Notice that we can eliminate x squared if I multiply equation 1, everything by 5, equation 2, everything by negative 3. Then when I add these two together, we're going to get x squared to eliminate. Okay, so 5 times 3, we get 15. 5 times 2, we get 10. 5 times 26, we get 130. Negative 3 times 5, negative 15x squared. Negative 3 times 7, negative 21y. Negative 3 times 3, negative 9. We're going to add those together, eliminating x squared. 10 minus 21, negative 11. 30 minus 9, negative 121. We're going to divide over that negative 11. Y equals negative 11. Okay, so it doesn't matter which equation we pick, but pick one of them. We're going to plug in that y and see what we get for x. And what I did was just chose equation 1, but it doesn't matter which one I choose. I chose equation 1 and I'm plugging in y as a negative 11, which is what we just found. Okay, so that gives us 3x squared minus 22 equals 26. If I added 22 to the other side, 26 plus 22 would give us a 48. If I divide by 3, that's going to be 16. 48 divided by 3 is 16. I'm applying the square root, so I have to remember to apply that plus or minus. Square root of x squared is x, square root of 16 is 4. So the two solutions that we're going to get is a negative 4 and a positive 4, and y is negative 11. And so here's our solution for this nonlinear system. Okay, graphing. 3x squared plus 2y is 26. 5x squared plus 7y is negative 3. What we see is our solutions are where our two graphs intersect. Okay. Use substitution to find all solutions to the system of equations. Okay, so if we are using substitution, we need to pick a variable to solve for, and this one is going to be the easiest variable to solve for, and it's actually already done. Y is equal to 2x. So let's plug in using substitution. We solve for one variable, plug into the remaining. Okay, so that gives us x squared plus, instead of y squared, we have 2x squared. That's going to equal 25. So then we have x squared. If I take 2x times 2x, that's going to give us 4x squared equals 25. Combining like terms, that's going to give us 5x squared is 25. Dividing both sides by 5, we get 5. I'm going to apply the square root. So if I apply the square root, I have to remember plus or minus, and then the square root of 5 is what we get for x. Okay, so x is a positive square root of 5, and x is a negative square root of 5. But for our ordered pair xy, we also need a y-coordinate. So let's get our y-coordinate. We know that y is equal to 2x. If x is equal to a positive square root of 5, we just get 2 square root of 5. If x is equal to negative square root of 5, then we just get negative 2 square root of 5. And that should be our solution.